In year 2025 JEE Main, there was a question on the chapter ray optics as given here. That question is given here. It is supposed to be a very tough question, both concept wise as well as time consuming wise also, and therefore now uh, here I'm going to now discuss about the our solution of the question. Why? Because you may get something like similar question in the future also. Even though it's a tough question, I don't expect it to come very often, but then you would never know. And therefore you must know how to solve it. The point number two, then most of you also will be aiming for JEE Advanced. Therefore, at the advanced level, you must know how to solve this question. Now, let me just now describe what the question was. The question is about a convex mirror, and then the focal length is given, as well as the object location, object distance also is given, and the object is moving towards the mirror. And therefore, the usual question which will be asked is very similar data, but then they will ask you what is the velocity of the image. I just repeat, now object velocity is given, the image velocity will be generally asked. Whereas in this particular question, they are asking the acceleration of the image, which actually is a tough concept, tough for calculation wise also is very tough. Now, most of the students may not be able to know how to solve it. Now, after the exam is over, now the coaching institutions normally publish a solution. Therefore, well-established coaching solution also is given here. This is a very good way of solving the problem. Simple only concept in terms of concept is nothing but it is straightforward. Okay, differentiation. Now, differentiation of the mirror equation once will give you the velocity equation. Then the second differentiation will give you the acceleration of the image. Therefore, now, as a kind of a mathematical concept, it's not very difficult. Whereas now working it out and then doing the calculation is going to be a tough one, plus time consuming. Now, where I come into the picture is now this solution is there. The solution will be time consuming. Therefore, I am going to give you a shortcut method of doing it. Okay. Now, having said that, let's just go through what the solution is. Now, before that, we just want to go through the question very clearly. Let us see. Now, what is given is there is a convex mirror of radius of curvature is given r equal to 2 meter, which means focal length is going to be 1 meter. Then, then the object distance is given as 24 meter from the convex mirror object distance, and also now it is moving, the object is moving with a uniform speed. Okay, mind you, uniform speed, no acceleration of the object, okay, which is equal to 90 kilometer per hour. 90 kilometer per hour you can convert easily into meters per second as 25 meters per second. Okay, therefore now let me just now write on what is the data which is given. First is now u is given as minus 24, and before that focal length we can take it as 1. All this I am just dropping the units because it is all SI units. Then u is given as minus 24, and then du by dt, it is approaching towards the mirror means, therefore it will be a plus value, is given as 25 meters per second. This is all the data which is given. What is asked for is d squared v by dt squared. That means acceleration of the image is what is. Okay, this is what it is. Now let us see the solution which has been worked out nicely like this. Now, first is we have to find the value of v. Value of v by means of the formula which is there on mirror equation, 1 by v plus 1 u equal to 1 by f, right? So now that is the equation which is mirror equation here. Therefore, now putting the value of u and f, you would know V, but then we have to be careful about the sign conventions. Now, incidentally, I have another video lecture where I given a shortcut method which will avoid using this mirror equation. Not only mirror equation, that particular shortcut method will hold good not only for convex concave mirrors, it will also hold good for convex concave lens also. That means all the four kinds of lenses and then mirrors which you come across in the ray optics chapter, I have given you a shortcut method which will eliminate using this particular mirror equation or the lens equation. Lens equation 1 by b minus 1 by u equal 1 by f also is there to be used for the lens problems. Now, both these kinds of mirror equation, lens equation can be avoided, and then it will save a lot of time for you, because there are actually now two aspects. You don't have to use the sign conventions in my shortcut method, which will be a major headache removed, because sign convention you are likely to go wrong sometimes. And also now the second aspect is because you will be avoiding using this equation, mirror and lens equation, you will not be doing any kind of mathematical workout with the reciprocal values. Because as I said, now 1 by 25 centimeter plus 1 by 40 centimeter is going to be a headache dealing with the fractional values. Therefore, my method is going to be very simple. You can almost all kinds of questions on the lens and mirror we can solve mentally without having to do pen and paper, without even having to do any kind of calculation on the paper. Therefore, that particular video lecture I would suggest that you go through sometime. And now it doesn't matter for this particular purpose of this solution of this question. You don't really need to do that particular shortcut method right now, because you can, even if you don't know it, you can use this particular simple equation, mirror formula, and then get the value of V. Now, value of V as what they are given. Now, they had used a different formula which is derived from this mirror equation only. They had used this particular formula UF by divided by U minus F, which will give you the value of V straight away. And therefore, let me just now write down what is the value of V, which is getting 24 by 25 plus. Okay. I can also now draw the figure for you so that it will be clear for you little. Now this is the focal length. This is the focus, which is 1 meter, and the object is here. Object 24 meters. And then the image is going to be erect, which is going to be like this at 24 by 25, less than 1 meter. Okay, F is equal to 1 meter, 24 by 25 meter. Okay, that's what is now what is given. Then okay, they also calculated magnification 1 by 25. It's really not required, but in any case you can just calculate it if you want it. Okay, they had used it. They are not used this magnification at all in the following workout. Now the second step is now differentiating this mirror equation is going to give you du by dt and dv by dt relation. Now dv by dt is nothing but velocity of image. You just see this, dv by dt is nothing but velocity of image, whereas du by dt is going to be velocity of object. Now this value is given, velocity of object is given, right? Du by dt, velocity of object is given 25. Now dv by dt we have to calculate from this particular differentiation equation. Now this where is, now already most of you or all of you will be knowing the well-known result pertaining to this velocity of image. Velocity of image is given by minus v squared by u squared times velocity of object. Okay, all of you may be knowing, because this can be, this actually is a well-known result, which is like this, dv by dt divided by du by dt, which is nothing but dv by du, which is nothing but, you will get this very famous well-known result, u squared. Now this is actually got in this solution. They have actually got this particular well-known result again by means of differentiating it here. You just see this, differentiate this respect to time. What you get is, for the first one is minus 1 by v square dv by dt. Now they made a mistake here. It is not actually a plus. You'll also have to get a minus here. Okay, now that's a mistake. What has been made here? It should be a minus. Okay, so now we just go back again. Minus 1 by v square dv by dt. Now here, as I said earlier, this refers to velocity of image. This refers to velocity of object. And therefore from here you get this. Velocity of image is equal to minus v squared by u squared. Now here they have done correctly. That is, they have only taken the minus sign and what I have corrected now. Therefore the what is. Now you know this, we already have calculated at 24 by 25, and then you already calculated as, u is already given as 24 is the data which is given. Minus 24, they put 24 squared is okay, fine enough. Then multiplied by velocity of object also is a given data, 25. We just put it here. Then finally you get the velocity of image as minus 1 by 25. Now, why do we require the velocity of image is because of this next step. Because you don't stop with the velocity of image formula, you have to go down to acceleration of image formula, which means now you have to take this particular formula and then expression, and then differentiate it once more in order to get acceleration of the image. Or rather, you have to take this particular expression what you have got, velocity of image equal to minus v squared by u squared b velocity of object, and then differentiate once more to get this particular value. There you would actually require the velocity of image and velocity of object values. Therefore you need to have this velocity of image calculated handy. Now this is what, and therefore now what have you got here is, we have to write down this velocity of, that is, and therefore this value is nothing but velocity of images. When you put the values, you get a minus 1 by 25. Why the minus is because when the object is moving like this, the image is going to come towards the mirror, therefore it's going to negative. Okay, that explains why this is negative. Anyway, now that's what it. Then differentiating once more is going to be the time consuming and the error prone step, because this particular step is going to give you a lot of headache. Why? Because now differentiate it, as long as you are very careful you will not make a mistake, but then most likely you may go wrong. Okay, differentiate it like this. How it is differentiated mean, now this you take it as one variable, therefore it is now minus 2 v by u, and then differentiate v by u again with reference to time. That means follow the usual v du minus, that is equal to u by v formula differentiation. Here what happens is, therefore it is now v dash u minus v u dash divided by u squared times v naught. They put it here, and then give all the values what you have got. What have you got? This is now velocity of image. You have already got it as minus 1 by 25. Then u is equal to minus 24. Then v equal to 24 by 25. And the velocity of object already is a given data, which is 25. Divided by u squared is 24 squared. And the velocity of object you have got. Therefore, now putting all these values, you will get it as acceleration of the images as minus 2 by 25, which is nothing but equal to 0.08. Therefore, now they are asking a numerical question. It is, and therefore now a you have got as 0.08. Therefore, they are asking 100a, what is the value? The answer is 8. Okay, fine. Now this is what it is. Then where is my shortcut is coming in here is only in this particular long time consuming double differentiation, second time differentiation step is where I am going to suggest a shorter method or a shortcut trip. Okay. Up to this, then there's not much. As I told you again, I have a shortcut for actually calculating without having to use the mirror or the lens formula. Okay. Now, that is going to save you a certain amount of time as well as the headache of going wrong. Whereas now the second shortcut specifically for this particular problem is avoiding the double differentiation. As I said, now this step also can be avoided because this is a well-known result already. So already you know this particular step as a well-known result. Therefore, now avoiding this particular second time differentiation to get the acceleration, I do by means of a quicker method. Let us say what is the quicker method is like this. Now we take this particular equation, which is nothing but dv by dt. Now, by the way, I'm going to now do the shortcut simplification while writing the steps also. Now, I simply write this as dv equal to minus v squared by u squared into du. Now here, when I say now dv, actually it means dv by dt. And this is also a dv by dt. That means this is now velocity of image, this is now velocity of object. Okay, that is understood. Now, therefore, now when I now do a differentiation here now again, it's now d squared v by dt squared. That is the acceleration I am going to get. Okay, this is what now they have done that particular differentiation here. I am going to do a simpler method. What is simpler method is I am going to borrow the concept of error, fractional error. Okay. By the way, that is, I am going to explain what is the particular concept from the fractional error I am going to borrow. It's like this now. Suppose now you have a expression or a formula like this: z equal to minus 3x squared by y power half. Okay. Then you know from the maximum error possible chapter concept, delta z by z, that fractional error in z is given by twice delta x by x plus half delta y by y. Okay. Now even though the y power half is there on the denominator, you still add it because in the error chapter you are concerned about the maximum possible error in delta z, maximum possible error in z. Therefore, now whether it's denominator also you are adding it here. Okay, this is a well-known concept to you. Now, I'm going to borrow this concept here. I'm going to say now the delta in the dv, the left-hand side is dv. Okay, left-hand side is dv. Therefore, now I'm going to say now delta in dv is nothing but d squared v. Now, fractional this thing is, fractional means d squared v by dv. Where now d squared v represents acceleration and the dv represents velocity, as I told you. I'm going to drop writing the particular dt every time. Okay, which is nothing but now the minus sign doesn't come into the picture here also. We just watch here, even the error this thing also, minus or plus doesn't come into the picture for a further calculation about the fractional errors. Very similar here also. Now minus I am not going to use. Okay, minus doesn't come into the picture. Whereas this is now equivalent to twice delta v by v. Delta v I am writing as dv by v, and then usually for this particular error, this thing we are taking it as a plus, no. Whether it is denominator also, we are only adding up the fractional error. Here there is going to be the difference. The difference is, if it is denominator, this is going to be minus 2 du by u. Okay, that means now here this now becomes, by means of using the error concept, this becomes fractional error is nothing, fractional error of the left hand side nothing but d squared v by dv Now d squared v is what we want as representing acceleration of the image. Okay, and therefore this is now like this, du by u. Okay, now I just repeat. Now the only departure from the concept of error, this thing is that the denominator, if it is so, then it's going to be minus. Okay, numerator is going to plus. Why? Because now what is the concept involved in this? Minus is like this now. Now if the numerator increases, then the left hand side is going to increase. Whereas if the denominator increases, left hand side is going to be decrease. Therefore, there will be a decrease in the fractional error on the left hand side if it is denominator. That's the reason why for this minus here. Okay. Now, having done this, that means we are now avoiding this particular long step of double differentiation by means of simply borrowing this idea from the error chapter. Now you put the data here like this. Therefore, now from here, continuing, therefore, acceleration of the image, which is nothing but d squared v by dt squared, is given by twice dv by v minus du by u multiplied by dv. Therefore, now we just do it now. This is nothing but 2 into what is now dv is already is known as dv, the velocity of the image, is nothing but minus 1 by 25 minus 1 by 25 times. Now 2 already taken. Therefore, now dv by v. What is dv is minus 1 by 25 into v is 24 by 25 minus what is du is plus 25, then what is u is minus 24. Therefore, this becomes minus 2 by 25 outside, and then this becomes minus 1 by 24 plus 25 by 24, which is nothing but minus 2 by 25 into this becomes 1. Therefore, final answer is acceleration of image is minus 2 by 25, which is nothing but minus 0.08. And therefore, they are asking numerical what is 100 times AI, which is nothing but 8, of course. Now they are asking the modulus value, therefore 8 is the answer. Understand? Therefore, now what we are doing, we are not doing anything which is great. We are only simplifying this double differentiation. First of all, what we are doing is we are now taking, we are avoiding this particular step here because this is already a well-known result. Okay. Then the second is now second time differentiation. We are avoiding this complicated double differentiation. Instead, we are using the concept from the error concept from the first chapter, like this. Okay, therefore it becomes very simple for calculating instead of this kind of a long time consuming error prone calculation. That's all. Okay. Now there are many more kind of examples which we can borrow from the concept of error concept, and then avoiding a lot of complicated differentiation later. Okay, there are actually plenty of examples which I have got, which I will be producing the video lecture also very shortly, and you can go through them. Okay, I'll give you a write up about which are those concepts which we can use from the error concept and then avoid complicated differentiation. Thank you very much.